Hello, and welcome to Single Cell Conversations with Lou, where we discuss all things single cell with our resident expert, Luciano Martelotto. My name is Tanmay Mishra. I lead product management and global marketing for single cell here at Waters Biosciences. In today's episode, we'll be discussing the various economic consideration for single cell genomic studies. Um, Over to you, Lou.
Hey, Timon, how are you? I'm excited to talk about this. This is one of my
Yes,
favorite
no.
topics.
Interesting topic. All right, so starting off, Lou, as we think about economic considerations for single cell studies, what is the real determinant of true cost of a study? Is it cost per cell? Is it cost per sample? Or is it something else?
Well, look, this is a very good question because it has several layers to answer it. But let me tell you what I think. So, I think it probably uh, focusing only on cost per cell or cost per sample, if you like, can be quite misleading, or at least a little misleading. Because to be honest, the real determinant of that cost is generating the actionable biological insights. There is no point to have a lot of cells if you don't have any biology in there. So for some studies, the cost per cell is important because you're trying to profile very large populations, or maybe identify rare cell types. But in other cases, the cost per sample becomes more important because you are running large cohorts of samples and you need statistical power across many patients or conditions or treatments, right? So, but beyond those two metrics, researchers should be asking themselves, did I generate the data quality or and the biological resolution that I needed to answer X question or my question, right? So if I had to repeat the experiment because of pool cell recovery or the performance that happened to be inconsistent or the data quality that is not sufficient, then those savings are apparent and will disappear pretty quickly. So what I do is typically encourage my collaborators or researchers in general to think about the total study economics, not just one part. Sample preparation, cell recovery, reagent costs, sequencing requirement, data quality, computation needs, the likelihood of obtaining any publishable answer uh, the first time, so without having to repeat many times. So ultimately, I think the cheapest experiment is often the one that delivers the answer, whatever that may be, without needing to be repeated.
You mentioned a few things that go into the cost, the true
Mm.
cost that you were talking about. Is the, in your mind, is there one that's more important than the other when you think about this order of
Right.
benefits that you were talking about?
Look, I think that, because this is cost, I think cost is definitely an important consideration. I mean, something that you have to have in mind and it's always in the mind. But it's from my experience and what I've seen with other people, it's rarely the only decision factor. I mean, money is important, but it's not the only thing, and it's really the most important one. And for most researchers, I typically consciously or unconsciously may balance in at least three categories: the cost, right, to make the decision, the cost, the labor, and the data outcome. Labor is something that typically is get forgotten, right? So first, so there's the direct cost of running the experiment. That's the essential, the easiest number to compare or to calculate, because it's the only part, but it's not the only part in the picture, right, that we have here. So the second is the labor. That is to me something that it's never considered. Sometimes grants become shorter because the labor that is required to do an experiment. Kids can be extremely time consuming, or the whole experiment. Sometimes you don't need, it's not one step, it's many steps. So it can be quite consuming. Sample preparation is very consuming. So labor is very important. How much, and what you measure that is how much hands-on time is required, how many manual steps are involved, how many people do you need to do that, what's the training burden of the new users. You have to train people, and a workflow that saves several hours per run by removing a couple of people or times on those people, or reduces the opportunity for user to user variability, right? Can certainly have a huge impact in the productivity and reproducibility. I would say third, and probably the most important to me, is the quality, and for a lot of people, and the usability of the data. You know, if most of researchers care about the cell recovery, or flexibility of the experimental design, scalability, capability with different sample type, to be able to do many samples, and ultimately whether the platform can answer the biological question that they ask. Okay, so at this moment, what we are seeing is that the study becomes larger and larger and larger, and as that happens, data processing and analysis becomes insane. So there are a lot of important consideration there. So you can generating data is only part of that little trip or journey. So we need to find solutions for those things. So I guess to sum up here, I would say that cost per cell and cost per samples are important metrics. They are usually evaluated not by themselves, but alongside scalability, flexibility, easy to use labor requirement, and confidence in the data, that you're producing. Yeah.
You said something about labor cost. Now, looking at the evolution, the number of cells per study, the number of samples per these studies is growing. Um, and given the labor cost, where do you think automation plays a role in solving this problem? Is there a particular use case that you see automation fulfilling? Where do you think it fits?
I think for single cell, and I would say for other, the subsequent technologies like spatial, for example, automation will be absolutely essential. There were some attempts of early on automation, but they were uh, unfortunately failed attempts. So I think any new ideas around automation would be very useful, especially for larger labs. So I would say that, like I said before, as the studies scale, automation becomes one of the most effective ways, I would say, to reduce project costs in general, even if the direct cost of reagents doesn't change. Because, like I say, it's not about the cost of the reagents only; it's about a lot of things. So the biggest advantage, I would say, for me is the consistency. Like you don't have to repeat the experiment because something went off. So that saves time and money, and in hours of the people that are running that. So where you are processing dozens, hundreds, or even thousands of samples, many of these workflows are very subjected to or sensitive to variability that could affect, of course, data quality, and then you have to repeat the experiment. So if an automation works really well that allows you to standardize the sample handling, and so you can facilitate or increase the reproducibility across the runs and operators and such, then you have a winner then. So, and the other one is it reduces the hands-on labor, right? So you can have super skilled scientists doing very mundane things like library preparation today, right? 10
Absolutely.
years ago, library prep wasn't a mundane thing. Today it is. So you don't want to spend, you don't want them to spend time on that. So they can, like, which is very repetitive. So what you want to do is just to move it into something a little bit more rewarding. For example, interpreting the results that they have, right? Or learning how to do AI, or some a little bit something that give them the opportunity and time to understand the data. So I think automation. Sorry, go ahead.
No, no, go ahead.
No, I was saying that I think automation, it's of course is more important for large cohorts. It's an obvious one there. Smaller labs are really unlikely to be able to put, that if you have 3 or 4 samples, they don't need that. But for large scales, pharma company, big labs or core facilities, I think anything that is doing translation research, biobanking effort, multi-site collaborations, right? That's a key one. Any project where high throughput is required in a way. So those situations, any small efficiency uh, multiply quickly across many samples. So Now, the other thing is, I want to say here to be clear, automation is not just only about the speed, all right? So, yes, there is a lot of speed there that you facilitate, but it's about creating the way that I like to see is about creating a workflow that can scale while maintaining the data quality and consistency. So the single cell studies are getting very high and very large and very complex. So I think automation is going to have a huge impact in these type of studies, and and they have two type of components. One is the scientific component, and the other is the economic component. I think this is a good time for one of those.
That's good, great insight, Lou. Um, any advice in closing for researchers that are considering different options on what they should think about in total cost?
I think in terms of total cost, they need to think about. I no, I'm not a particular. I'm not a fan of the cost per cell. Okay, I think it's been introduced in the field, and it's very. It can be very misleading. Cost per sample. It's only important when you go across a huge cohort. Cost per cell. It gives you an idea, like I said before, if you're studying a lot of cells, right? Because you have to sequence those cells, right? Even if your kit can accommodate those cells, and your profiling kit can accommodate those cells. But I think that they need to think about the entirety of the cost of the kit, the cost that it takes, the workflow, how long it takes, the cost of the your postdoc or a PhD, or if you have to do your experiment, the cost of the computation, the cost of the tips, the cost of the things that every little thing that you need for that, and then budget that, and you realize what it's the best direction. Is it worth it to do that? Because I've seen many cases. I want to do single cell, and they realize that the budget is limiting the number of studies that they can do, the number of samples, the number of cells. So it depends on the question, I would say, right? So in some cases you need more cells, in some cases you need more samples. But like I say, I'm not a particularly fan of saying, "Oh, my cell is one, my experiment is one cent per cell," because that it's only focusing on a particular, very narrow set of metrics or factors that are contributed to the value. There is it's way more than $1 per cell or 1 cent per cell.
Absolutely. This is very valuable insight, Lou. I think this is all we have time for in this episode. So thank you so much for taking the time. Until next time, and for the next episode of Single Cell Conversations with Lou.
Awesome. Thank you very much. See you next time.
See you. Thank you.